Hi everyone. As you can tell, here's another video. Hopefully you're enjoying your late start. And today we're going to move on to 1.6, which is the transformation of functions. I do apologize for my previous video yesterday. Maybe there was a glare off my glasses. I normally don't watch my videos again, so I do sincerely want to make sure you could see what you're learning today. Today, because we have a short class, I just wanted to break up this lesson called from section 1.6, Transformation of Functions, part 1. There's two aspects of the transformations that we have to learn in grade 11. And the first one is super easy. That's why I'm going to get this out of the way. And tomorrow we'll tackle the more challenging concept. So let me share my screen with you. First of all, with your handout. I am going to deviate just a little bit from what you were given. Hopefully you can see from your screen. 1.6 talks about exploring transformation of parent functions. I'm going to change up this lesson just a little bit. We will eventually go through all of these. Let me just scroll through it. And we'll talk about what those numbers represent. But I really am looking at example 1b, 2b, 3b, and 4b. And this will make sense in a different context. So please grab yourself some graph paper. I'm going to turn off my camera again. And I'm going to stop my sharing for a second. I am going to just pivot and switch to my Word document. So grab some graph paper, and I'm going to teach it a little differently. Let me share my screen again. So from 1.6 transformation of functions, my goal is to teach you this generic function notation. And what you see on your screen is how the textbook teaches it. Other schools use a different notation, but I'll only comment about this. Y equals A, F, K times X minus D plus C. This is called the function formula or function notation of a function, and it's just a general form. So today's class, yes, you see how many letters? Y, A, F, K, X, D, C. Seven variables. But technically, we're learning only about 5 of them. And one of them is going to make more sense, even though it's in blue. So technically, there are actually 4 variables we have to get across. Now, what we would like you to understand in the transformation unit is understanding what is happening to these functions. So we're going to focus on today the C value and the D value. I like going in this order. I like doing C first, then D second. Tomorrow we'll talk about A, and then the hard one, which is K. Let's get this out of the way. What does F stand for? It just stands for function. That's all it is. F stands for function, and it'll make more sense when we look at the parent functions tomorrow when I see you in class. You do not have this example, so pause the video if you would like to see this. What we have is a blue function, and this is f at x. Maybe I should zoom in so people can see a bit better. And what I want to get across today is the horizontal and vertical translation. But the first one we're going to take a look at is the C value. Now, what we're going to be doing is taking this blue function and transforming it. This transformation is so easy, and I wish I was there with you. You learned this in grade 10 when we described the quadratic or the parent function. Recall, in grade 10, we talked about y equals a bracket x minus p squared plus q. So this lesson is looking at the q value and the p value. In grade 11, because your textbook uses different letters, this represents f at x plus c. Let me just scroll back up. Notice I'm looking at the C value right here. So how are we going to understand this? This function is just a made-up one. I like using this one than the parent functions because the parent functions, although are very, very important, it doesn't help you understand the nuances. I wish we could use animation for this, maybe a anime figure or a character or an animated cell. But f at x plus c, this function we have in front of you, what we're going to do is look from left to right and take a look at their key points. I just made this up. Notice what I'm doing. This is kind of like the features of your cell phone when it takes a look at your unlocking your phone using photographic parts of your face, where your eyes lie, where your nose is, where your mouth is, even where your ears and eyebrows. It doesn't take the whole picture, although in the past, a lot of you know what we're going to be doing. Also, the neat connection is to motion capture or mocap. So what I've done is I've listed the key points of this function. And for this one, there are 5 key points. I'm going to list them down below. -6, 0, -4, 2, -2, 2, 0, -2, and 2, 0. This is our function. And yes, it's connected. They're all real numbers. But notice what we're going to do is transform this. Super easy. So for my example, I'm going to make up a function. We're going to transform this blue function. And let's just say we want f at x plus 1. Pause the video if you want to try to predict what's going to happen. What we're trying to get you across to understand what c is, this c value of 1 means to go up 1 unit. The specific word is actually a vertical shift up 1 unit. So what does that really mean? This one's super easy because many of you will understand it. We're going to shift all the values. Now, you're not going to do all the math for all the infinite number of points from -6 to 2. But I think you understand that that -6, 0, which I will highlight first off so you can see what I'm doing, that new transformation point is going to be right there. That's -6 and 1. Follow the same pattern. That new point, -4, 2, is now going to be at -4 and 3. The third point is going to be, and you guessed it, most of you can do this innately, and you've successfully vertically shifted this function up 1 unit. To illustrate this further, what you're supposed to get out of this is that the y values all seem to have increased by 1, but nothing changed for the x coordinates. So obviously, a lot of you can predict a vertical shift affects the y coordinate by adding or subtracting. Let's try another one. I'll change up the color so people can see it. We'll use orange. Let's just say I want to graph this function. Now we're going to go from the parent function or the f at x, the blue one. And let's just say I want to do this one. I'm going to write this off to the left of the screen. Y equals f at x minus 2. Pause the video if you want to try it, but I think you already know what we're going to be doing. The blue function is going to go vertical shift down 2 units. And I apologize, I spelt the first one. Maybe we should correct that. Make sure it's red. 1 unit. Back to the orange. Down 2 units. So just help everyone out. Just make sure everyone's following along. Again, I'm looking at this -6, 0. So the new point's going to be -6 and -2. The next point is going to be -4 and 0, -2, 0, 0, -4, 2, and -2. I like using a weird function for you so that you actually understand what the C does. So what you're seeing on your screen, I'm writing the key points from left to right, those functions. That's what C does. One more time, as a summary, when you have a plus C, it goes up C units. If you have negative C, it means to go down C units. I apologize. I'm going to erase the screen, so feel free to take a snippet or snapshot. And I'm going to use the same function for our next transformation. I apologize for the delay here. So now we're going to look at D. What is D? From grade 10, this was kind of like the p-value of our vertex form. Let me just erase some things. Hope it doesn't go all the way. I'm also going to erase the examples that you have on your screen so it just doesn't get jarring. The reason why I have a second grid, just in case I want to use this again, and I'm maybe going to show you with our parent function just really quickly. Oops. You know what? I'm going to leave that there because it's helpful. So now we still have our function. Notice since we have this function that we're going to look at, again, it goes from -6, 0, -4, 2, -2, 2, 0, -2, and 2, 0. I'm now going to look at the D value, and some of you will find this difficult, so please bear with me. What we're looking at is f at x maybe -3. Notice how it's written. Unlike a C value, which is outside of the parentheses or brackets. And just to be clear, technically, there's another square brackets there. It does get a little cumbersome, so I'm going to erase it because it's just too many brackets. And we'll talk more about that in class if you want to ask me more in detail. My goal is to actually make you understand what this D value is. And this is why it's a little confusing. When it's f at x -3, this type of transformation means a horizontal shift and now you have some trouble. It's right 3 units. So we're going to take that -6, 0. Hopefully I'm highlighting on your screen. And it's going to go 3 units to the right. So let's pause for a second. That -6, 0 ends up right there. That's why I think you understand now the translations or the shifts, the image of the function stays the same. It stays oriented the same. It looks almost identical. It just seems to be in a different position. Just like, for example, you're sitting in one seat and you decide to move to another seat. Nothing has changed about you. Also, when you go from the first floor to the second floor, you're also the same. Back to this. Try to predict where the new point of -4, 2 is going to be. And just to highlight it, it's right here that I'm looking at. And I think you already understand the new point's going to be right there. We are shifting right 3 units. And if you're still not too sure, the right is in this direction. Keep on going, -2 and 2. It shifts right 3 units. So it's going to be right there. That 0, -2 goes 3 units to the right. It's right there. And finally, the last point, 2, 0, it's going to go to the right 3 units. The blue graph and that purple graph, They're exactly the same, except one of them is shifted right. This one is confusing because in the function it says x minus 3, and I'll try to explain it more in detail when I see you. The last one we're going to do is a nice light green one, and I think a lot of you already can predict what I'm going to be doing. Oops, and I forgot to give you the equations. My apologies. Let's give you the answers. So a lot of you already know. I'm going to write it off to the right of the screen, if that's okay. That is not the same color. Let's try again, Mr. Chen. I think it was this color. Is that the same? I think it is. No, it is not. That is not the same color. My eyes are going. Recording videos all day eats up my time. I've been having problems, technical issues. I don't know how people in film can do this. Maybe I need to take Mr. Morgan's class or Ms. Hamilton's or Mr. Vajacic's class. So that negative 60, I apologize, I'm going to be writing it over here to the right. Notice what it becomes. Negative 30, negative 1, 2, 1, 2. I should have given myself more room. 3, negative 2. I apologize, this is down here. 5, 0. And if you're not too sure, when we shift horizontally, notice it affects the x coordinate by adding by that shift, adding. Last one before we actually look at something. I think I was going to use green. I'll try to pick it up. Try to predict what's going to happen for this one. F at x plus 1. Pause the video if you want to try yourself. Taking that parent function, a lot of you understand. It's a horizontal shift. I'll just short form this so it fits. Left 1 unit. So this negative 60, and let's just clear this up so people can focus. Hope it works. I'm looking at this negative 60, and it shifts right there. That negative 4, 2 shifts right there. The negative 2, 2 shifts right there. That 0, negative 2 shifts right there. That 2, 0 now shifts right there. 1, 0. This is why some of you, and I actually went to Pittsburgh last year, and I visited the Andy Warhol Museum. There's some famous paintings that actually show this nice little shimmer, the transformation. I wish I could show you the artwork. Maybe I'll have a chance to show you in class. But this is really, really neat. The blue function has shifted left 1 unit. So to show my work for this, pause the video if you want to try to do it yourself. A lot of you already know it's going to be negative 7, 0, negative 5 and 2, negative 3 and 2, negative 1 and negative 2, and then 1, comma 0. And if you're not too sure, when you shift left, you subtract by 1. So hopefully you understood what I was trying to focus on with the C and D, the translations. Vertical shift means to go up. Horizontal shifts mean to go left and right. So let me give you the summary down below here. I apologize, I'm off screen if you can't see it. I like writing it like this. So when you see x minus d, and this is the d value, it's a right d units. And if you see x plus d, it means left minus d units. That's plus, that's minus. So the ones I'm going to just pivot back. Let me just stop this sharing. And I'm going to now share back the original functions. You can actually now quickly do these questions. And that's what F stands for. Now we're going to scroll back up, and I'm only going to do just one of each, just so that you can see it. My apologies, 1B. Let me make this a little bit larger. So y equals x squared. You should know that this is a parabola from the parent functions that we've looked at. That's the parent function. Pause the video if you want to challenge yourself. Y equals x squared plus 2. What do you think this plus 2 is? Is this a D or is this a C? You guessed it right. This is clearly a C. So what does that really mean? It's going to go up 2 units. This is why I do not like this package, is because my graph is off the grid. My last one I'm going to do. What is y equals x minus 1 all squared? What is this? You guessed it, it's a D. We're going to take that blue function and we're going to shift it right 1 unit. Now, if you're not too sure how we're doing this so fast, don't panic. Let's give you the parent function key data. And I think you can figure this out yourself. With the C value, I added 2 to all of those Y values. If I wanted just to do the plus 1 to the right, I added 1 to all those X values. Slowly you're understanding that D and C actually affect the X and Y coordinates of any key feature. So hopefully it made sense. And again, we can actually review this tomorrow's class. We'll obviously look at A and K. A, some of you already have an understanding because it is the vertical stretch or vertical compression. K is the hard one, but we'll talk about that tomorrow. Please, 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 as always, if you have any questions, see me in class for extra help. Hopefully this made sense. Hopefully you enjoyed these 3 videos that I've made for you. And again, I do sincerely apologize for not being there for you. Thanks for watching.